Hi, my name is Kyle Blauer. I'm the Field Research Manager at the Cal Poly Strawberry Center. I'll be reviewing the results from our 2020 Fungicide Efficacy trial for controlling Botrytis gray mold.
The cultivar used in this study is the ever so popular Monterey, planted into your standard raised bed. This is considered a small plot study replicated 4 times with 5 spray applications over a 4-week period. Prior to the first application, we remove all pre-existing fruit from the trial area, leaving only the flowers. We apply the products with a handheld backpack sprayer. After all the applications, I'll evaluate these treatments by determining the level of Botrytis incidence in the field and collecting fruit for a post-harvest evaluation. This is an example of what the post-harvest evaluation might look like. We store them at room temperature and monitor them every 2 days. The tray on the left is switched with a weekly rotation of Captan, and the tray on the right is the non-treated. The idea here is that all the fruit are similar in ripeness. A little white shoulder is okay, but definitely no bruises or rot. So jumping to 6 days after harvest now, your eyes are probably immediately drawn to all the rot on the non-treated tray, but there are actually 6 berries on the switch rotated with Captan side. This is a dramatic difference here with only 3 berries on the non-treated tray that do not have gray mold. This would statistically separate, and I would classify switch rotated with Captan as an effective fungicide treatment. And that's the purpose of this trial, is to find treatments that statistically reduce the level of Botrytis gray mold to not spraying at all. I'm going to run over what you received as part of your field handout titled Fungicide Efficacy Trial Against Botrytis Gray Mold. I'll start with the green graph titled Early Season 2020. Note that the x-axis is only set to 45 here. I reduced it to help show some differences between treatments. And dropping in the field evaluation, in this case it was 3 days after the final application, and we see pretty low pressure. The non-treated in the red box only had an average of 2.7%. The yellow or gold box is a treatment we put in all our Botrytis trials. We also refer to this as the grower standard. We know that switch is very effective for controlling Botrytis fruit rot, and Captan is widely used, so this is a benchmark as a standard treatment. But you're not going to see any statistical letter codes because nothing statistically separated. The disease pressure was just too low, and that was partially due to the warm weather and little rain during the trial. And frankly, that happened all year long. Now looking at the post-harvest evaluation 4 days after harvest, we see statistical separation, and there are actually 2 treatments at the top here that did significantly lower the amount of gray mold relative to the non-treated. Moving on to the yellow graph from the handout, this is the peak season trial. Note that the x-axis has changed to 70, and we can see the low pressure in the field evaluation again. The non-treated in red was at 1.8%. To put this low pressure into perspective, usually I like to see at least 10% here. I want to test these products in extreme conditions, and to increase the disease, I will use sprinklers to prolong the leaf wetness, but when it's warm and windy, it really doesn't matter how long those sprinklers are on for. The sun and wind will evaporate that water quickly and not create a conducive environment for Botrytis to grow. It's all about prolonging that leaf wetness to get a lot of Botrytis in your trials. There was even one treatment here that yields 0%, but we still don't see any separation because there was also one rep in the non-treated that yielded 0% Botrytis. When the non-treated has 0% in one of its reps, it's impossible to separate the treatments. But this is what happens sometimes in field trials, and there's really nothing you can do about it. Looking at the 6 days after harvest, there was one treatment that was significantly separated at the top of the graph. It may appear that this trial had higher pressure, but that was because this data is from 6 days after harvest, not 4 like the early season. If we were to look at the other evaluation days, nothing statistically separated, so that's why I chose these two dates. I get this question a lot of why we store these at room temperature and not 34 degrees like a commercial strawberry grower. And that's because mold doesn't grow at low temperatures very rapidly. We want to test these products in extreme conditions, and there's nothing more extreme than leaving your berries out at room temperature overnight. What's next in your handout for this talk is a fungicide efficacy table. I just have the few first lines on the slide so we can see them clearly. We compared data from our fungicide trials that we have conducted over the years, and we are working with the University of California to update the table located on the UC IPM website. Each fungicide gets an efficacy rating. 4 pluses is the max. NR means that that particular pathogen is not listed on the label. In some cases, we have found some level of control, so you'll see NR in parentheses with some pluses as its efficacy control level. ND means no one has tested it for this pathogen yet. Ideally, if we want to continue to update this, I would like to see no NDs on this table. The superscript R's mean we have recorded resistant populations from strawberry fields throughout California or confirmed the results here at Cal Poly. This table is subject to change when officially published by UC. You'll be able to tell what version of the table you're looking at by the Cal Poly logo and date on the bottom corner. Ideally, we want to be on the same release time, but we wanted to get this data out to you, so we have released it early. And lastly, the plan for next year is probably 2 more fungicide trials for Botrytis gray mold. I think we'll assess to see how much of a problem rhizopus and mucor rot are in the industry because there's not a lot of products that can control it. So we want to help get registration if this is a regular problem, but the first step is to see where this pathogen is. I know we can get it here at Cal Poly, especially during the warmer late summer months of the year. For the next round of efficacy trials, I want to come up with an inoculation method to help further separate treatments. I'm not going to leave it up to Mother Nature to create a good disease pressure environment, so I think that would add a lot of value to these trials. We can also look at resistance at the same time as these trials are going on and continue monitoring the change in populations. All this information we are gathering would be updated in that fungicide efficacy table I just talked about. That seems to be the easiest way to relay our findings is in that table. And thanks for taking the time to listen to me today.